The most important detail about the Tesla Semi-Atlas refresh is not the leaked images. It is where those images were captured. Nevada. That location matters. Under Tesla, Nevada is not used for styling experiments or concept testing. It is where battery validation, thermal stress testing, and heavy-duty endurance work happen. When a vehicle shows up there in an altered form, it usually means the design is already past the idea stage. Early sightings point to a visibly revised front profile, wider stance, reinforced geometry around the lower fascia, and a more muscular overall shape compared to the current Tesla Semi. Those changes are not cosmetic. They suggest Tesla is preparing the Semi for sustained real-world freight use, not limited pilot programs. Freight operators do not care how a truck looks. They care about axle loads, cooling under continuous stress, and structural fatigue over hundreds of thousands of miles. The front-end changes hint at improved load, distribution, and stronger crash structures designed to handle higher, more consistent payloads. That aligns with what long-haul operators demand, trucks that perform the same way on day 1 and day 1,000. Cooling is another key clue. The Atlas refresh appears to feature larger air inlets and revised airflow paths. In electric trucking, heat is the enemy of reliability. Motors, inverters, and battery packs operating under constant load generate enormous thermal stress. A redesign at the body level suggests Tesla is addressing lessons learned from real freight data, not simulations. This is how Tesla typically operates. Design changes only happen when manufacturing data and field use prove they are necessary. Under the leadership approach of Elon Musk, products are hardened through use, not speculation. That means Atlas is likely the result of thousands of freight miles, operator feedback, and internal performance metrics showing exactly where reinforcement was needed. This is not a concept refresh. It is an operational one. Before we continue, if you want calm, structured analysis that focuses on real-world trucking impact rather than social media hype, please subscribe my channel so you do not miss the next part. In the next section, we will break down what these design changes imply about payload capacity, durability, and why Atlas could signal Tesla's full commitment to electric long-haul trucking. What the Atlas design changes reveal about payload and durability. The Atlas refresh is not about making the Tesla Semi look tougher. It is about making it stay tougher over time. The most telling signals from the Nevada sighting point towards structural intent. A wider stance and reinforced front geometry almost always indicate higher sustained axle load tolerance. In commercial trucking, peak payload numbers matter far less than payload consistency. Fleets care about whether a truck can haul near its maximum load every single day without accelerating wear. That is what Atlas appears designed to address. By redistributing stress more evenly across the front structure of chassis, Tesla reduces long-term fatigue on suspension components, steering, assemblies, and frame mounting points. Over hundreds of thousands of miles, those small stress reductions translate into fewer failures and longer service intervals. Durability is the real upgrade here. Under Tesla, design revisions rarely target a single component in isolation. Changes tend to cascade through the system. A reinforced front structure improves not only crash performance, but also how loads transfer through the chassis during braking, cornering, and uneven road surfaces. This matters for electric trucks more than diesel ones. Electric drivetrains deliver torque instantly and consistently. That constant force places different stresses on the frame compared to combustion trucks that ramp power more gradually. Atlas appears to be Tesla's response to real-world data showing where reinforcement improves. Longevity under electric-specific load profiles, cooling improvements further support this conclusion. Larger intakes and revised airflow channels are not for occasional hill climbs. They are for sustained high-load operation across long distances. Heat buildup degrades batteries, inverters, and motors faster than almost any other factor. By redesigning airflow at the body level, Tesla is signaling confidence that Atlas is meant for continuous duty cycles, not limited routes. Under the leadership approach of Elon Musk, products evolve only after use exposes weaknesses. Atlas likely reflects freight data gathered mile after mile, not theoretical modeling. This is why the Atlas refresh matters. It suggests Tesla is no longer asking whether the Semi can work in real logistics operations. It is refining the truck to optimize it for those operations at scale. In the next part, we will examine what Atlas could mean for fleet adoption timelines, production readiness, and whether this refresh signals Tesla's transition from pilot programs to full commercial rollout. What Atlas signals about fleet adoption in Tesla's timeline? The Atlas refresh does more than improve the truck itself. It sends a signal about where Tesla is in the electric trucking timeline. Pilot programs are about learning, refreshes are about committing. When a manufacturer revises structure, cooling, and load management, it usually means the product is being prepared for scale, not experimentation. Fleets do not deploy thousands of trucks unless durability questions are already answered. Atlas suggests Tesla believes those answers are now clear enough to move forward. Under Tesla, production upgrades tend to follow a pattern. First comes limited deployment, then data collection, then targeted redesigns that remove friction for long-term customers. Only after that does volume expansion begin. Atlas fits squarely into that sequence for fleet operators. This matters because adoption decisions are not driven by innovation headlines. They are driven by risk reduction. A refreshed Semi that addresses thermal stability, structural fatigue, and serviceability lowers the perceived risk of electrification. That shortens decision cycles. Instead of asking whether electric trucking can work, fleets begin asking how quickly they can transition. Once that question changes, adoption accelerates. Atlas may also reflect manufacturing readiness. Design changes that simplify load, distribution, and cooling often pair with production optimizations. More consistent builds, fewer component variations, easier service access. All of these reduce downtime, which is one of the biggest cost drivers for commercial vehicles. If Atlas is entering production preparation, it likely means Tesla is aligning factories, supply chains, and service infrastructure for broader deployment. That does not mean overnight transformation. It means predictable scaling. Another important clue is where Atlas was spotted. Nevada is deeply connected to battery production and powertrain validation. A semi-refresh there suggests Tesla is finalizing how the truck behaves under sustained electrical load, not just how it looks or drives, that aligns with a move from pilot routes to long-haul use cases. Under the leadership approach of Elon Musk, Tesla tends to push products until economics, not ideology, determine outcomes. Once operating cost advantages become undeniable, expansion follows naturally. Atlas appears to be the version of the Semi built for that moment. It is not a publicity vehicle. It is not a concept. It is a refinement designed to remove the last objections fleet managers raised. In the next part, we will look at how Atlas could affect operating costs, service intervals, and why this refresh may quietly tip the total cost of ownership decisively in Tesla's favor for large freight operators. The cost equation Atlas is quietly targeting. The most important impact of the Atlas refresh is not visual. It is financial. Electric trucking only wins when the numbers hold up under pressure. Not during test runs, not in controlled pilots, but across years of non-stop freight movement. Atlas appears designed to attack the three cost categories that matter most to fleets: downtime, maintenance, and energy efficiency under load. First, downtime. Reinforce structure and improve thermal management, reduce the likelihood of forced pull-offs caused by overheating or component stress. In commercial freight, every hour a truck is not moving is lost revenue. Even small reliability gains compound into large savings when multiplied across hundreds of vehicles. Atlas suggests Tesla is prioritizing operational consistency, not peak performance. That is exactly what fleet managers want. Predictable trucks beat impressive trucks every time. Second, maintenance. Improved load distribution across axles reduces uneven wear on suspension, brakes, and tires. That extends service intervals and lowers parts replacement frequency. Atlas also appears to simplify access to high-wear components, which shortens repair time and reduces labor cost. For fleets, this is critical. Lower maintenance does not just save money, it simplifies planning, fewer surprise failures, fewer trucks sidelined waiting for parts, more reliable scheduling. Third, energy efficiency under real freight conditions. A truck that performs well empty but struggles under load does not survive commercial deployment. Atlas appears optimized for sustained heavy operation, which means better efficiency per mile when hauling maximum payloads. That directly affects cost per mile. When electricity consumption becomes more predictable under load, fleet operators can forecast expenses more accurately. That reduces risk, which is often the biggest barrier to adoption. Taken together, these changes suggest Atlas is not chasing headlines. It is chasing total cost of ownership dominance. This is where electric trucking becomes unavoidable. Once the cost per mile advantage becomes consistent across routes, weather, and payloads, resistance fades quickly. Fleets do not care about brand loyalty. They care about numbers that hold up under scrutiny. Atlas appears built for that moment. In the next part, we will examine why Tesla might be refreshing the Semi now, how this timing aligns with broader industry shifts, and what it suggests about when large-scale electric freight adoption could accelerate faster than most people expect. Why the Atlas timing matters more than the design. The Atlas refresh is not happening in isolation. Its timing may be the most revealing detail of all. Electric trucking has reached a pressure point. Fuel volatility, tightening emissions regulations, and rising maintenance costs are forcing fleet operators to reassess long-term strategies. Diesel trucks are becoming more expensive to operate and harder to justify over multi-year contracts. At the same time, early electric pilots have already proven something critical. The technology works. What has been missing is confidence at scale. That is where Atlas comes in. A refresh at this stage suggests Tesla believes the remaining barriers are no longer technical. They are operational and psychological. Fleets need proof that electric trucks can run day after day, year after year, without unexpected failures or runaway costs. Atlas appears designed to remove those doubts. By reinforcing structure, improving thermal margins, and optimizing for sustained heavy loads, Tesla is signaling that the Semi is ready to move beyond controlled deployments. This is the version built for routes that do not get special treatment. Routes that run in heat, cold, traffic, and long-haul conditions without exceptions. The timing also aligns with infrastructure maturity. Charging networks for heavy vehicles are expanding. Depot-based charging strategies are becoming standardized. Grid integration planning is improving. These developments reduce friction for fleets considering electrification. Tesla refreshing the Semi now suggests alignment between vehicle capability and supporting systems. That alignment is crucial. History shows that adoption accelerates rapidly once multiple constraints disappear at the same time. When vehicle reliability, operating cost, and infrastructure readiness converge, hesitation fades quickly. Atlas may represent that convergence point. It is not meant to convince skeptics through marketing. It is meant to quietly satisfy the spreadsheets that logistics executives rely on. Once those spreadsheets turn favorable, adoption does not happen gradually. It happens in waves. This is why Atlas matters. Beyond design. It marks a transition from proving electric trucking is possible to proving it is inevitable. In the next and final part, we will bring everything together and explain why the Semi-Atlas refresh could be remembered as the moment electric freight crossed from experiment to default, and what that could mean for the trucking industry over the next decade. Why Atlas could mark the turning point for electric freight. When industries change, the moment is rarely obvious at first. It usually looks incremental. A refresh, a redesign, a quieter upgrade that does not dominate headlines. That is exactly why the Semi-Atlas refresh matters. Looking back, this version of the Semi may be remembered as the point where electric freight stopped being a trial and started becoming the default. Not because it introduced a single dramatic feature, but because it removed the final reasons fleets had to hesitate. Atlas addresses durability, uptime, and cost predictability in a way that aligns with how trucking actually works. Long routes, heavy loads, tight schedules. Minimal tolerance for downtime? These are not theoretical requirements. They are daily realities for freight operators. By optimizing for sustained operation rather than demonstrations, Tesla is signaling confidence in the platform, confidence that the technology is mature enough to survive years of punishment, not just months of testing. This is how adoption usually accelerates. Once a few large fleets validate the numbers at scale, others follow quickly. No one wants to be the last operator paying higher fuel costs, higher maintenance bills, and higher downtime penalties. Competitive pressure does the rest. Atlas also reframes the conversation around electric trucking. Instead of asking whether electric trucks can work, the question becomes whether diesel trucks can remain competitive. Once that shift happens, momentum changes direction fast. The Semi-Atlas refresh does not need to outsell every diesel truck immediately. It only needs to prove that electric freight can operate reliably and profitably under real-world conditions. From there, the economics speak for themselves. That is why Atlas is important. It is not a showcase product. It is not a concept. It is a signal that electric freight is moving from early adoption into normalization. If you want clear, structured analysis like this that focuses on real-world impact rather than hype, please subscribe my channel so you do not miss upcoming breakdowns on Tesla, trucking, and electric transportation trends. This series on the Semi-Atlas ends here, but the industry shift it represents is only beginning.